You ever wonder how Netflix instantly knows what to recommend after you finish a show? Or how your bank can spot a weird transaction and flag it in milliseconds? Well, a lot of the time, the secret ingredient is this powerful, kind of hidden engine called Apache Kafka. And today, we're going to pull back that curtain and see exactly how this thing works. The answer? Well, it all comes down to taming this just insane flow of data. I mean, we are talking about literally every click, every single sensor reading, every transaction happening all at once. The scale is just mind-boggling, right? And to handle that, you need a totally different way of thinking about how software talks to each other. And that different way of thinking, it's called an event-driven architecture. So instead of one system constantly bugging another, like, hey, got anything for me yet? How about now? Systems just shout out what happened. They announce, hey, a user just clicked a button into a central place. And then any other system that actually cares about button clicks can just listen in and do its thing. It's way more efficient. To make this super simple, think about your home theater setup. Your PlayStation doesn't talk directly to your speakers, right? Nope. Everything plugs into one central receiver, and that receiver routes all the signals to the right place. Well, Kafka is basically that receiver, but for data. And that's the big idea we're going to unpack. All right, so here's our game plan. We're going to follow the life of one little piece of data. First, what even is Kafka? Then, we'll look at how an event gets created by something called a producer, how it's stored in the cluster, and then how it's used by a consumer. After that, we'll zoom out, look at the whole ecosystem, and really get into why this stuff matters so much. All right, section 1. What is Apache Kafka? You know, the best way I've heard it described is that it's like the central nervous system for a company's data. Okay, so the official kind of nerdy definition is it's a distributed event streaming platform. Let's actually break that down because those words are important. Distributed just means it runs on a whole bunch of servers at once. So if one server fails, no big deal. The whole system keeps on chugging. And streaming platform, that means it's built for a constant, never-ending river of data, not just, little messages sent one at a time. So how does data even get into this river? Well, that's where our first character comes in, the producer. This is ground zero for every single event. The producer's job is actually pretty simple, but it is totally critical. Think about it. Something happens. Anything. A user clicks add to cart on a shopping site. Bam. The producer's job is to see that, wrap it up into a neat little message, and then just fire it off into the Kafka cluster. That's it. It's the source of all the information. Okay, so the producer fires off this message. Where does it go? It lands in the heart of the system, the Kafka cluster. And this, my friends, is where things get really, really cool. Because this cluster isn't just some temporary inbox. It's the source of Kafka's real power. See, these events don't just get dumped into a giant, messy pile. No way. They get neatly sorted into categories called topics. So you'd have one topic for all the user clicks, another for all the payments, another for sensor readings. You get the idea. It's like having perfectly labeled mailboxes for every single type of data. But you might be thinking, what if one of those topics, like page views for a huge site, gets enormous? How does it handle that? Well, this is the genius of Kafka's design. It takes that one massive topic and splits it up into smaller, more manageable pieces called partitions. And then, and this is the key, it spreads those partitions across a bunch of different servers, which Kafka calls brokers. This means you can process a ton of data all at the same time, in parallel. That's how it scales. Now, this next point is maybe the most important thing to understand about Kafka. It is not your typical message queue. With a normal queue, a message comes in, one thing reads it, and poof, it's gone forever. Kafka is completely different. Think of it like a logbook that can't be erased. An event gets written to the log and it stays there. It persists. This means the data can be read over and over again by all sorts of different applications. Okay, so we've got this permanent, unchangeable log full of data. So what? Who actually uses it? Well, that brings us to the final player in our little drama, the consumer. This is where the data actually gets put to use. And a consumer is really just any app that needs to do something with that data. It just tells Kafka, hey, I'm interested in the payments topic, and it starts receiving that stream of events as they happen. And this is where the magic really happens. This is the power of decoupling. Because that data log is permanent, you can have tons of different consumers reading the exact same topic for completely different reasons. So your analytics team might be slowly reading through the user clicks topic to build a report. At the exact same time, a fraud detection system is reading that same topic to look for weird patterns in real time. They don't interfere with each other at all. One can crash and the other just keeps on working. It's incredibly powerful. You know, Kafka started out as this really efficient data pipeline, but over the years, it's grown into so much more. It's a whole platform now. So let's take a quick look at the ecosystem that's built up around it. First, there's Kafka Connect. Honestly, this thing is a lifesaver for developers. It's basically a framework with a bunch of pre-built connectors that make it super easy to get data in and out of Kafka. So, want to pull data from a database? There's a connector for that. Want to push data out to your cloud storage? There's a connector for that too. You don't have to write all that plumbing code yourself. Then you've got Kafka Streams. This is a really cool library that lets you actually work with the data while it's in motion. So as the river of data is flowing by, you can build little applications that filter it or combine two streams into one or do real-time calculations, all on the fly. And finally, the schema registry. This is so important. Think of it as a strict contract or a rule book for your data. It makes sure that what the producer sends is in the exact format that the consumer is expecting. It prevents so many errors and basically stops a huge complex system from turning into total chaos. Okay, so we've gotten pretty deep into the technical weeds here, the what and the how. But let's zoom back out. Why does any of this matter? Why has Kafka become this foundational piece of the modern tech stack? Well, for one, just look at who's using it. We're talking about the biggest names out there. It was actually invented at LinkedIn to handle other activity stream data. Now you've got Twitter, Square, the list goes on and on. These companies rely on it as the absolute core of their data infrastructure. And that really gets to the heart of it. Kafka isn't just cool tech for the sake of cool tech. It solves real, critical business problems. You need real-time insights? That's stream processing. You need a system that absolutely cannot fail? That's his data replication and durability. You need different teams to be able to build new apps without breaking everything else? That's the whole point of that decoupled architecture we talked about. And it does all of this at a scale that is just staggering. So in the end, it all comes back to that first idea. Kafka is that reliable, scalable, central nervous system. It lets an organization feel and react to things as they happen, in real time, not after the fact when it's already too late. So next time you get an instant notification on your phone, or you see a sports score update the second it happens, just think about the invisible journey that data just took. You have to wonder, what part of your digital life is being powered right now by one of these hidden, silent streams of events?